Hello, viewers. In today's session, we are going to discuss a very interesting problem. And here we have to find the remainder when this number, that is 5 raised to 90 plus 7 raised to 90 plus 49 raised to 23 is divided by 6, right? So we have already discussed the concept how to solve these kind of problems, but here once again we are going to solve another important problem related to finding out the remainder when a large number is divided by some small number, right? So here the large number constitutes the sum of these three big numbers. So here we have 5 raised to 90 plus 7 raised to 90 plus 49 raised to 23, and when this sum is divided by 6, we are to find out the remainder, right? So let us start. So viewers, we have already discussed the concept how to solve these kind of problems. Let us revisit the concepts again, and here let us first take this number as y, right? So y can be written as 5 raised to 90 plus 7 raised to 90 plus 49 raised to 23. And now let us quickly see the concept which is used to solve these type of problems, right? See, when we write a number in the form, say x plus 1 raised to n, then x plus 1 raised to n can be written as 1 plus x times lambda, where this n is positive and lambda is also a positive integer, right? So n is a positive integer and lambda is also a positive integer. And similarly, when we express a number in the form, say, x minus 1 raised to n, then x minus 1 raised to n can be written as minus 1 plus x times, say, mu. Mu is again a positive integer, right? Now here we have two cases, right? So the first case is x minus 1 raised to n may be written as minus 1 plus x times mu, when this n is odd positive integer, right? And when this number n is even positive integer, then we can write x minus 1 raised to n as simply 1 plus x times of mu, right? So in the case of x minus 1 raised to n, we have two situations. When this n is odd, then we can write x minus 1 raised to n as minus 1 plus x times mu, and when n is even, then we can write 1 plus x times mu. And remember, lambda and mu are positive integers, right? So let us utilize these concepts to solve this problem. So let us first write these three numbers separately in the form x plus 1 raised to n and x minus 1 raised to n, right? So first we have 5 raised to 90, and 5 raised to 90 can be written as 6 minus 1, because 6 minus 1 is 5, and here we have the exponent 90, right? Now let us see that this expression 6 minus 1 raised to 90 is similar to this one, right? So x minus 1 raised to n, and here this power or exponent is even number, right? And it is even positive integer. So 6 minus 1 raised to 90 can be written as 1 plus x times mu, and here x is 6, this is x, so x is 6. So we can now write this number as 1 plus 6 times of mu. Now let us take the second number. So here we have 7 raised to 90, and 7 can be written as 6 plus 1 raised to 90. And again we can see that this form, that is 6 plus 1 raised to 90, is similar to this one, because here we have x plus 1 raised to n, and here we have 6 plus 1 raised to 90, right? So this case is valid for all values of n, that is positive values, irrespective of the fact that whether n is even or odd, right? So here again x is 6, so we can write this number as 1 plus x times lambda, right? So here we have 1 plus 6 times lambda. Now let us take this number. So here we have 49 raised to 23. Now 49 raised to 23 can be written as 7 square, because 49 can be written as 7 square, and here we have 23. Now we can multiply these two numbers by the laws of exponents. So we have 2 times 23. So this is 7 raised to 46, right? And now 7 can be written as 6 plus 1 raised to 46, right? And we can see that this form is similar to this one, that is x plus 1 raised to n. So here again x is 6, so we can now write 6 plus 1 raised to 46 as 1 plus x times lambda, right? So here I will write it as 1 plus 6 times of say t, right? Because we have already used the notations lambda and mu here, so we are here using another notation, that is t. And remember, mu, lambda and t are positive integers. So once we have expressed these numbers in this form, we can now write this number y, which is equal to the sum of these three numbers. We can write y is equal to 1 plus 6 mu, because 5 raised to 90 is 1 plus 6 mu. Then 7 raised to 90 is 1 plus 6 times lambda, and then here 49 raised to 23 is 1 plus 6 times of t, right? So now we have to simply add these numbers. So here 1, 1 and 1 gives us 3, and here we have 6 mu plus 6 lambda plus 6 times t. We can write 3 plus taking 6 common in these three terms, we have 6. Then we have mu plus lambda plus t, right? And remember this sum, that is mu plus lambda plus t, may be replaced by some other positive integer, say p, right? So we have here p, so this is now 3 plus 6 times of p. So now we have expressed this number y as 6p plus 3, right? And this statement indicates that this 3 is the remainder when this number y is divided by this number 6, right? So whenever we write a number, say y, in this form, y is equal to 6p plus 3, then this term 3, it gives us the remainder when this y is divided by 6, right? And here p is some integer. So the remainder in this case, when this number is divided by 6, is 3, right? So yes, this is how by using this concept we can solve these kind of problems.